There we are. So standard deviation is like range. And the thing about range is that if you add the same number to everything, well, the range doesn't change. Think about it. If you have, let's say the numbers 1, 2, and 3. Everybody tell me, what is the range of these three numbers between 1, 2, and 3? Type it in the chat box. Right, the range would be 2. And that's because we would subtract the highest and the lowest. That's the range. Now think about it like this. If I were to add, let's say 5 to all of the numbers, we now have 1 plus 5 is 6, 7, 3 plus 5 is 8. If you add the same number to all of your data points, what's the new range going to be? Well, what's 8 minus 6? Still 2. Still 2. And that's because if you have a set of numbers and you add the same thing to all the numbers, will the numbers get any further apart? They will not. And that's the same thing with standard deviation. Standard deviation is not from top to bottom. Standard deviation is from the middle outward. What's the average distance from the middle, from the average? And so the thing is, hey, if we add the same thing to all of the numbers, will the numbers get any more spread out? They will not. And that's why the standard deviation remains the same. So everybody, does that explanation make sense? Do we see why, even if we were wrong, even if we were right, do we see why this answer is correct? Let me know. Yeah, perfect. Hey, thanks for the love. Awesome. Sounds good. So that's the idea here. If all of the numbers are increased by the same amount, the range or the gaps really do not change. So there we go. So there we are, guys. Let's go ahead and try out number 2. Number 2, let me go ahead and reset my watch. Let me reset my timer here. All right. Give me a yes if you're ready for number 2. Give me a yes if you're ready for number 2. All righty, sounds good. 5, 4, 3, 2, 1, go. There are 9 receipts in a basket. Number does whole numbers from 0 to 8 without repetition. If 3 receipts are picked with a replacement, and if the 3 picked numbers are arranged such that the number picked first is placed in the hundreds digit, the number picked second is placed in the tens digit, and the number picked third is placed in the units digit of that number, then what is the probability for that number to be more than 499? I'm going to give us just a little more time here on this one. I'm going to give us 2 minutes, starting now. Remember, do not reveal your answer when you're done. Simply type ready in the chat box. All right, I'm gonna give us just about 15 more seconds here to wrap it up. Remember, on the GRE, you are not penalized for an incorrect answer. So if you have to guess, please be okay with taking a guess. All right, 5, 4, 3, 2. Answer is, what is it, everybody? What do we get? We got B, B, A. What else do we got? That's only 4 people. Come on, everybody else. What do we have? We got B, B again for the Neela. And who else? No, that's not everybody. That was only about 10 people. I know some of us are sitting back and just watching. Got C, A. All right, cool. So we have a bunch of different types of answers that we're seeing here, and that's completely okay. So I want to make sure that we understand how to get the right answer. The right answer is B. It is B, 4/9. So hooray, congrats if you got it. But here's the thing, guys. Remember, it's not about getting the question right. It's about knowing that we can get the next one right. That is the goal. So let's go ahead and explore why B is that answer. Because here's the thing. With word problems, nobody likes them. There's a lot of wording. There's a lot of things to go over. But I'm telling you, with a strategy, you will get these right. So remember, interpret, plan, compute. Because I'm going to show you that this problem is not as bad as it looks. So here we go. Remember, when you read it for the first time, you only want to see what you can imagine. So only talk about what's real, what you can actually see. So there are 9 receipts in a basket. Okay, 9 receipts. Numbered as whole numbers from 0 to 8 without repetition. If 3 receipts are picked with replacement and they're arranged such that the number picked first is in the hundreds digit. Okay, so this is really important now. I'm not going to imagine this, but I am going to highlight this. Number picked first is hundreds digit. Picked second is tens digit. Picked third is the units digit. Then what is the probability for that number to be more than 499? So here's the thing. When I read this for the first time, I said, okay, we have 9 receipts in a basket. And what we're trying to do, what it seems that we're trying to do, is that we will pick out one receipt. That will be the first number that we place. Another receipt, the second number, the third receipt, the third number. The only difference is that they are picked with replacement. And what that means is if you pick one receipt up and you see the number 5, you're going to write down the number 5, and then you put the receipt back in the basket. So that's what it means to have with replacement. Without replacement would look like this. You grab the receipt, you write 5, and then you throw the receipt away. You do not use it again. So in this problem, they say with replacement. And the thing is, it actually doesn't matter if it's with or without replacement for this specific situation. Let me go ahead and explain why. So I've imagined the situation. Like I said, you just want to imagine the situation and you want to identify what your goal is. My goal is probability. I want to know the probability for that number to be more than 499. So we want probability. And remember, probability is done in the following way. To find probability, we will divide. We will divide the desirable outcomes by the total possibilities. All right, we're dividing the desirable outcomes by the total possibilities. So what we want divided by everything that's possible. And so let's go ahead and think about this now. If we're picking 3 receipts, that means that the first number is in the hundreds digit. The second number that we pick is in the tens digit. And then the third number that we pick is in the units digit. So if I pick out one receipt and I get 5, then I put it back, and then I pick another number and I get 2, and I put another number, and then I get another number and I get 9. That would be the number, 529. So everybody, can we imagine that so far? Can you give me a yes or a no so far as to whether we understand this? Because from here, now we're going to take over. Perfect. So here we go. What I want you guys to notice is that they want it to be more than 499. So think about it. If you want it to be more than 499, that means we need 500 or more. That's what we need. And here's the thing. Look at the other two digits, the 0 and the 0. It doesn't matter what they are, because if you have a 5 as the first number, that's 500 something. If you have 6, that's 600. 7, 700. 8, 800. And so the thing is, the other two digits don't matter. These do not matter. As long as this is a 5, 6, 7, or 8, that will be greater than 499. If it's a 4, it doesn't matter what other numbers they are, it will not be greater than 499 because the max you can get to is 488 because you're going from 0 to 8. So do we see that, guys? Do we see that the other two numbers don't actually matter? It's only the first digit that we have, that hundreds digit. Do we see that? Let me know, because that's the key to this problem. A lot of us may think that we have to actually use these other two digits, but we really don't. We really don't. So let me go ahead and help us out here. Sorry, let me adjust that. So let me help us out in saying that, hey, as long as we have a 5, 6, 7, or 8, we're good. And so boom, those are 4 total numbers. How many numbers are there between 0 and 8 inclusive, guys? How many numbers is that from 0 to 8? Yep, exactly. That's 9 numbers. So we have 4 over 9. Boom. That's the probability right there. That's all you needed to know. So did anybody take a more complicated approach and see that it's a little easier? Let me know. Who took an approach that was a little more complicated? And just acknowledge it. Oh, you did? Okay. It was there. So did it get you with the tens and the ones unit? Was that what it was? Because if that's what it is, yeah. Yeah, see? So for real, yep. Yeah, you tried to solve for the last two numbers. 388 divided by 888. Did that still give you 4 out of 9? Oh man, those are yeah, it looks like we got some crazy answers here. Yeah. And that's okay, guys. That's completely all right. That's completely all right. I am here to make sure that we're making that progress. So I'm glad that I can help you out with that problem. So with that said, who's ready for number 3? All right, let's go ahead and get ready. I love the excitement. I love it. I love it. I love it. All right, so number 3, guys. Number 3, let's get to it. Question number 3. If the measures of possible side lengths of a triangle are to be chosen from the set S equals 3, 5, 7, 9, and 11 without repetition, what is the probability of choosing 3 side lengths at random such that they form a triangle? All right, we have 1 minute and 45 seconds and go. Remember, interpret, plan, compute. You got this. Remember to not reveal your answer until we're ready to go. All right, we just passed the 1 minute and 45 second mark, but we are going to go for another 25 seconds to see if we can get more people ready for an answer. Hey, it's quite all right if we're stuck. Just make sure you understand where you are stuck. So try to think about what makes sense so far and then what doesn't make sense. That's where we want to focus. That's where we're going to focus. All right. So if you need to take a guess, take a guess. 3, 2, 1. Answers. What do we got? D 0.6. All right. D 0.6. All righty. Okay. Some say E. D, mostly D, mostly D. All right, let's go ahead and see what the answer is. Let's go ahead and see. Because what we want to do here is, before I reveal the answer, first things first, read the context. So if the measures of possible side lengths of a triangle, possible side lengths of a triangle, I recognize that. That's triangle inequality theorem. If you don't know that, don't worry. I'll take care of that in a moment. But I see possible lengths of a triangle chosen from this set of numbers without repetition, probability of choosing 3 side lengths so that they form a triangle. So what I'm imagining right now is a triangle. And can everybody hear me okay? Just making sure, because I have someone telling me that they cannot hear me. So go ahead and let me know if you can hear me all right. You can hear me? Perfect. All right, sounds good. So I don't know why this person can't hear me. I'll address that in a moment. But here we are. I'm imagining a triangle, and I'm saying, hey, okay, there's a set of numbers that I need to pick from to form that triangle. I can't repeat the numbers. Okay, I can't repeat them. But I want to know the probability of choosing 3 sides so that they form a triangle. So remember, guys, to get probability, that is the same thing as what we want divided by what's possible. All right, what we want divided by what's possible. And so to get that, here's what we do. When it comes to a problem like this, I understand that those numbers need to form a triangle. And for me to understand which one of those combinations will form a triangle, I'm going to have to list everything out. I'm going to have to list everything out. I have to. All right. If you don't list it out, you can't just guess. This is one of those situations where you actually have to look at the numbers and assess each one. So what that tells me is that this is not a problem that I can just simply calculate. This is a problem that I actually have to do, and it's just going to take me a little bit of time, and that's completely okay. So do you see what the key there was, though? They're asking us which of these can form a triangle. So you're not going to have 5 million, 5 million possibilities. That is not going to happen. That is crazy. They want to know which of these form a triangle. So we're going to list out all of the possible sets. So because the thing is, they don't expect us to do everything if it's a big, big, big number. So here's how we're going to do it. We have the numbers 3, 5, 7, 9, and 11. What I'm going to do with those numbers is I'm going to go ahead and just write out all of the different combinations that I can. So I'm going to start off with 3 and 5, and then I'm going to have 7, and then I'm going to do it again. So 3, 5, and then 9 now, then 3, 5, and then 11. Do you guys see how I'm organizing this? I'm trying to organize this as easily as possible by starting with the lower numbers that I can. So I did 3, 5, 7, 3, 5, 9, 3, 5, 11. Now I'm going to proceed by going ahead and using 3 and then 7. So I have 3, 7, then 9, then 3, 7, 11, right there. So up next, what we're going to use is, in black, 3, 9, and then 11. Now, up next, I'm going to continue this. By grabbing red here, and I'll start off with 5 now because I've already exhausted everything with 3 in the beginning. So now I'm going to start off with 5. So 5, 7, 9, then 5, 7, 11. I've exhausted all of those with 5 and 7. So now I'll go with 5 and 9. And then the only option is 11. Then lastly, my very, very last option has to be 7, 9, and 11. So give me a show of hands. Give me a yes or no. Who understands that we have to actually write out the set here? We actually have to write out the possible outcomes with this type of problem. Perfect, great. So now this is where we're gonna go. Remember, we said that we have to form a triangle. Remember, we said that from the very beginning, and it's very important that we keep that idea in our heads, because here's what we're gonna do. We're gonna apply the triangle inequality theorem. All right, the triangle inequality theorem. So there's two ways of writing it. The first way that I'm going to show you here, this is the only way I'm going to show you here, is that the short sides, any two sides that you add, they have to be larger than the third side. All right, that is the triangle inequality theorem. If you add two sides, they have to be greater than the third side. That's exactly what we're going to use. Yes or no? Did you know about this inequality before? Yes or no? Did you know this? That the two sides have to add up to the bigger than the third. Perfect. So with that said, here we go. All we're going to do is go down the list of numbers here and then check it off or cross it out. So here we are. 3 and 5. Is that bigger than 7? Yes or no? Bigger. Perfect. That checks off. We're good. Let me move this over so I have more space. All right, next. 3 and 5, is that bigger than 9? It is not. So I will cross it out. Next, 3 and 5, is it bigger than 11? Obviously not, because that would be 8. What about 3 and 7? Does that make it bigger than 9? Yes, it does. 3 and 7, is that bigger than 11? It is not. 3 and 9, is that bigger than 11? Yes, it is. 5 and 7, is that bigger than 9? Yes. 5, 7, is that bigger than 11? Yes. 5, 9, is that bigger than 11? Yes. 7, 9, is that bigger than 11? Yes. So we have 1, 2, 3, 4, 5, 6, 7 different combinations that we like. How many total possibilities are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our answer is 7 divided by 10, or 0.7, which is E, actually. Actually E, not D. I know a lot of us chose C or chose D, believing that it was 0.6, but maybe we went a little too fast. Maybe we guessed, or maybe something in between. But do we understand that? Perfect, sweet. That's awesome, guys. And then is there any other way to find all the possibilities? In this particular instance, no. Simply because this is a situation where you have to assess every possibility on its own. It's not like you just list it and then you can see where something falls in it. There's no short trick here for this one. This is a problem where, hey, you have to immediately understand what you have to do and do it as quickly as possible. Because the thing is, if you knew that, hey, oh, this is combinatorics with triangles, oh, I just have to list this thing out, you can do this within 2 minutes. Yeah, you can get it done within 2 minutes for sure, but you just have to understand as quickly as possible that that's what you have to do. If you don't understand it, then it's going to take you longer. Eamon, with the combination formula. So from 5, pick 3, then you would do 5 prime divided by all that. But honestly, it really wouldn't help because you have to list everything anyway. Because you have to list everything anyway, you'll see that it's 10 no matter what. So you wouldn't actually have to use the 10 combined 3. You wouldn't have to. So no worries. Yeah. Hey, good question. That's a very good question. Thanks for asking. All right. So we still have 20 minutes and we still have a couple more questions to go. Who's feeling good so far? Who's feeling like this is helping you out? Was this worth it so far? Prayers, that's fast. Yeah, perfect. Perfect. Sounds good, guys. Let's go ahead and go to question number 4. Go. A circle circumscribes a square with side length L. What is the probability of choosing a point inside the circle but outside the square? This one, I love this question. You have 2 minutes again. I'm going to give you 2 minutes. Do not reveal your answer. Go. Was there correct? Six, five, four, three, two, one. Answers. What do we got? We got E, A, C, D. We got everybody going in different directions here. So someone has to be wrong here. Someone has to be wrong. E, C. All right, what else we got, guys? If you have, take a guess if you have to. Take a guess. There's 23 of us in here. Come on. What guess do we have? All right, sounds good. So the answer to this question is actually A. It's actually A. So, hey, good stuff. Good stuff. You got it. So, but here's the thing. I don't care if you got it right. I really don't care. What I care about is, can you explain why you got it right? Because the thing is, in life, we can get lucky, but can we be consistent? That is the question. So here's how we do this. And don't feel bad if you got it wrong, because I'm going to show you how you get it right. So here we are. So a circle circumscribes a square with side length L. Remember, think about everything you can imagine. If I'm talking about a circle, and this circle circumscribes a square. The word circumscribe, it means that whatever's following. So if the circle circumscribes the square, it means that the circle has a square inside of it. So we can go ahead now and draw or imagine a square inside. So there we are. We have a square inside of a circle. And then the side length of the square, actually I'll just use black. The side length is L. So I can say that this is L, 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 if I'd like to. Now here's where the question comes in. It says, what is the probability? Okay, so remember, I'm already thinking for probability. What I want divided by total possibilities. And then choosing a point inside the circle, but outside the square. So here's what they're saying. They're saying, let me use a highlighter here. They're saying, hey, a point inside the circle, but outside the square. So they're saying, hey, what about, can we pick a point that's in this area or this area or this area or this area? That's what they're saying. That's what they're saying so far. Can we pick a point in that shaded region that's outside the square, but inside the circle? And here's how we're going to get there, guys. Here's how. Notice how we have the entire circle, but then we're taking away the square in the middle. So what we want, again, I'm going to say that again in English. We want everything inside the circle except the square. So here's what we want. We want the circle, but we want to take away the square. But what's the total possibility here? What's the total here? Well, the total is, well, you can pick anything inside the circle. So the whole circle is the total. So again, we want everything inside the circle. Let me just change sizes here. We want everything inside the circle, but outside the square. So we need to take that square away, and the entire possibility is picking anything inside the circle. So give me a yes if we understand that so far. Give me a yes so far. Perfect. So again, one more time, it's what we want. It's the circle except the square. And then the total possibility is just the entire circle. Now, what are we trying to talk about here, though, in terms of picking somewhere inside? What mathematical idea are we discussing? I got you, Sephora. Give me one moment. What are we talking about? Picking a point inside the square. What mathematical idea are we thinking about in terms of points in area? Ramshad, perfect. We're talking about area. Notice how I shaded these. Notice how I shaded all of this. And that's because we're talking about area, a shaded region. So that is area. That's what we're discussing. So what we need to do now is find the area of the circle, subtract the area of the square, and divide it all by the area of the circle. Remember, the probability is dividing what we want by the total possibilities. That's how we get probability. So what we need to do here now is just the following. Find the area of the circle, the area of the square, and then do your math quickly and you're done. So let's go ahead and get to it. How do we get either of them first? Well, I know that the area of the square is actually a little easier because we have the square of length L. So how do we get the area of a square again, everybody? Remember, it's the side squared, which in this case will be L squared. So far, so good, everybody? Perfect. Now let's go ahead and talk about that circle. This is going to be a little tougher. Remember, the area of a circle will be pi multiplied by the radius squared. So the question now becomes, how can we get the radius of this circle? That's the question. So let's go ahead and reveal that answer. Remember, if we're taking a look at this circle, something very interesting happens. That green line that I just drew, this green line, that is the diagonal. The diagonal of that square is also the what of the circle. That green line right there is also the what of the circle? The diameter. This is the diameter. This whole thing is the diameter. We want the radius. So we want half of it. We want half of the diameter. So I need to work to figure out what the radius is. That's what I want. But how can I get the diameter first? Because the thing is, remember that the diameter, it's half the radius. The diameter, oh, whoops. The radius is half the diameter. I can't believe I even did that. That's funny. It's really early for me. I haven't had my coffee yet, so give me a break. All right, so there we are. The radius is half the diameter. So what we need to do is find the diameter. What can we use, guys? What mathematical idea can we use? Yes, Ramsha, Pythagorean theorem. Yes, this is a right triangle that if we were taking a look here at this piece, that is a right triangle. We have length L, we can find the diameter, which would be, let's just call it D. So here's how the Pythagorean theorem would go. We'll have L squared plus L squared equals D squared. From here, we add them together to get 2L squared, which will be D squared. Then what we'll go ahead and do is take the square root of both sides. So then we have D equals square root of 2 multiplied by L. And there we are. And so then if we want to receive the radius, remember the radius is half of the diameter. So I will take my diameter and cut it in half. Just like that. So there we go. That is my radius. That was a lot, right? I know we just went through a lot of work for no reason. There was a reason, guys. We're trying to solve this problem. So there's my radius right here again. That's where I want to insert it. So then we will have pi multiplied by all of this squared. So let me just figure out what all of that squared would be. If we square it, we will have the square root of 2 multiplied by itself, which will become 2. L squared is L squared. 2 squared is 4. So I had to square everything. So now I'm going to simplify this before I put it in. So that would be L squared over 2. So again, this right here is the radius squared. So that's what I'm inserting right here for the radius squared. So that would be pi multiplied by L squared all over 2. So now that we have all of this, now what we're going to do is now plug it all back into everything we want. This is exactly what we were trying to do from the very beginning, right? So remember to stick to the plan. That's why it's so important to outline your steps. So here's what we have. I'm going to move all of this and make it smaller because I'm going to answer my question now. My probability equals the area of the circle, which is pi L squared divided by 2, minus the area of the square, which is L squared, all over the area of the circle, again, which is pi L squared over 2. So with that said, here we go. What I will do is I'm actually going to split this fraction up. We have this minus that divided by this. What I'm going to do is I'm actually going to split them up into 2 separate fractions. So allow me to erase what's on the denominator here, or in the bottom, and let me show you. My probability, I'm going to split it up again into 2 separate Who knows why I did this? What's going to happen over here? Who knows why I did this? Yeah, it's cancel. It cancels out. It simplifies to 1 because anything divided by itself is 1. So I did that on purpose. This becomes 1. That becomes 1. Now I'm going to subtract, and over here, when we have a fraction divided by a fraction, what we will do is we will keep, change, and flip. Keep the numerator, change the symbol to multiplication, and then flip my denominator. So that would be 2 over pi L squared. And so to make this look a little easier, you'll move this over here. And what's going to cancel out on that right side? Help me out, everybody. What's going to cancel with that fraction? Exactly. The L squared is going to cancel. Therefore, we will erase the L squared, leaving us with 1 minus 2 pi. That is my probability. That's exactly what I was looking for earlier. 1 minus 2 pi, or 2 over pi, excuse me. And there we are. That was the answer that we chose. Boom, we are good. So I know that was a lot of illustrating, that was a lot of drawing, but was that helpful? Because I know everybody here got it wrong, except for 2 people. So who feels like that, really helps you in terms of the next problem that you might see like this? Perfect, guys. So remember, just to recap, with this problem, here's what I did from the very beginning. I said, hey, I see the word probability. So let me just start off with my basic knowledge of probability. What I want divided by what is possible, the total possibilities. Then from there, you want to move quickly to figure out what you want and what the total possibilities are. I know I took a long time to explain it because really I'm teaching it. So I have to explain every step. But for you, it's up to you to practice more and more and more to get a problem like this down to about 2 minutes and 30 seconds. We will not possibly finish this in 1:45, but think about it like this. There are problems in the GRE, quantitative reasoning, that will only take maybe 30 to 45 seconds. That means that there are other problems that might take more than the 2 minutes, more than 2 minutes and 15 seconds, possibly even more than 3 minutes. So it's about managing your time. If you can get the easy problems done quickly, then you'll have more time to do the harder ones. Does that make sense, everybody? Sweet, because I want you to know that problems like this are not impossible. They are not impossible, all right? So we did have another question lined up, but no worries, that's all good. We are out of time, but please stay with me for just a couple of more moments because I want to make sure everybody feels okay. So how do we feel, everybody? How do we feel? How do we feel about this session? Yeah, you do get actually, yeah. As you get similar questions on Scholar Den, yep. These questions are from the website. These are from the website, and every single one of those problems is going to have a video solution by me on that website. So I really appreciate you asking that, because if we need more practice, if this presentation was useful, that's why I really believe that, look, we need to have a good approach to every problem, and we need to have access to more problems. So here's the thing. What we need to do, remember, is interpret. Interpret the problem. Imagine what's going on and point out the things that you recognize. Don't try to hurt your brain by trying to reach out and see what is there that you don't see yet. No. Just take what you have. Take what you have. What do I understand so far? Then make a plan. Then see what the connections are. Notice how earlier we said, okay, probability. I know that that's what I want. Divided by possibilities. I'm talking about area. Oh, we're doing the probability of the areas. Boom. And then we connected everything and then we did our thing. That's what I'm talking about. And then remember, don't pick up your calculator unless you're ready to pick it up. I didn't know that I had to find area first from the very, very beginning. It was only until I recognized, hey, I have to find area. I have to actually apply the formulas, use the L, then I'll use my calculator and compute, or then I'll go through the steps. Too many people have a bad habit of picking up that calculator first, and that is the easiest way to fail. So there is the 3-step plan. Interpret the problem, plan your steps, and compute the solution, just like that. And so moving forward, I want you to familiarize yourself with the test and the concepts. Continue learning about the test, making sure that you're practicing consistently with strategy, and time yourself to simulate that test environment. The 1:45 seconds is the approximate time you get. So time yourself every time. With that said, I know I'm only running these sessions once a week, but I want to get your opinion, guys. So give me a live feedback here. Here are the 2 options that we have moving forward for these group tutoring sessions. weekly, and I can make them free, right, for these sessions. If I want to run another one, possibly do 2 in 1 week, I'll be very honest. I am going to have to charge an entry fee or registration fee. So if I were to do that, what would, let's say, would $5 or $3 be something that you could agree to? Because I know $10 might be a lot. I know 15 or 20 might be a lot. But would something like $3 to $5 be worth it if we went over, let's say, a guaranteed 10 problems? So if we went over 10 total problems, would it be worth it to pay? Let me know, guys, and be honest. You be honest, because I want your opinion here. Would it be worth it for, let's say, $3 for Khalid? Yeah. Would that be worth it? Yeah. And we would go over maybe like 10 questions, not just 4 like we did here. We would make sure that we go over all the questions, and in their entirety, I would record the session, and then I would send it out to everybody after the fact as well. So even if you miss the session, you can have the recording. Yeah? Think it'd be worth it? All right, sounds good. So yeah, I'll go ahead and make it like that. I'll go ahead and do that, okay? Because the thing is, I care about you guys' success. I care about your success, and I want to make sure that we're doing the most fair thing possible. So here's the thing. Even if you can't attend the sessions, let's say you don't want to watch the recordings, let's say you just want a bunch of practice problems, we've got your back too. If you go on scholarden.com, this is where you're going to find over 350 problems. The thing is, look, practicing and self-assessing is key. You guys said it. And that's why Scholarden is so successful in raising your score. What they do is insane. I've only been with the team for about 2 months. And what they've shown me, what they can do with people in terms of raising their score and getting them to the college of their choice, it's amazing. It's outstanding.